Alright, let's talk about hydrates for a second. Right here on the page, I have a hydrate. And I know it's a hydrate because I have these 7 water molecules attached to the copper 2 sulfate. Imagine we had a copper 2 sulfate. I drew it in a little cloud here to visualize it. And what that star, or you will see dot 7 H2Os, means is that I have 7 water molecules attached to the copper 2 sulfate. So I took the liberty of drawing 7 water molecules surrounding the copper 2 sulfate. What we want to do is we want to figure out how much the salt portion, and this is the salt right here, the copper 2 sulfate, how much the copper 2 sulfate weighs in terms of gram formula mass, and how much the water part weighs in gram formula mass. So we're going to take the copper, the sulfur, and the oxygen. We'll look at how many of each one of these we have. So we'll take the copper right here. There's only one of them. Sulfur, there's 1. Oxygen, there's 4. 1 copper, 1 sulfur, 4 oxygens. We'll look up on the periodic table the atomic mass of copper, sulfur, and oxygen. Copper happens to be 64. Sulfur is 32, and oxygen is 16. If you don't know how to calculate gram formula mass, go back and watch the other video on calculating gram formula mass. And then we're going to multiply them out, 64, 32, and 64. And we're going to add those together, and we're going to get 160 grams per mole. Now let's go ahead and calculate how much the water's atomic mass or gram formula mass is. We're going to take hydrogen. There's 2 of them. Oxygen, there's 1 of them. Each hydrogen has a mass of 1. Each oxygen has a mass of 16. We're going to get 2 and 16, and that is 18 grams per mole. However, there are 7 water molecules. So we're going to do 7 times 18 equals 126 grams per mole. Whoops, that went off my page, but you get the idea. Alright, that tells us the salt portion of this copper 2 sulfate weighs 160, and the water portion weighs 126. When we add these together, we're going to get a total mass of 286 grams per mole. So the entire hydrate, that's the salt and the water, has a mass of 286 grams per mole. Okay, let's try another hydrate. Again, this is a hydrate that has 5 waters on it. So we've got magnesium, we've got sulfur, and we've got oxygen in our salt. There's 1 magnesium, 1 sulfur, and 4 oxygens. We're going to look up the mass of magnesium, the mass of sulfur, and the mass of oxygen, and we will find that magnesium has a mass of 24.3. We're going to round that to 24. Sulfur has a mass of 32, and oxygen has a mass of 16. We'll do the math. 24 times 1 is 24, 32 times 1 is 32, and 4 times 16 is 64. When we add all of those together, we've got the salt, just the salt in the hydrate, weighs 120 grams per mole. Okay, I moved that little guy to the side. Now let's deal with the water portion of this hydrate. In this water portion, we've got a water molecule which is made up of 2 hydrogens and 1 oxygen. We've got hydrogen, we've got 2 of them. We've got 1 oxygen. Each hydrogen weighs 1 gram, each oxygen weighs 16 grams. We're going to multiply them through. We're going to get 2 total mass for the hydrogen, 16 total mass for the oxygen, and we're going to end up with 18 grams per mole. That's for 1 water molecule, but we have 5 water molecules, as indicated by this coefficient right here. So we're going to take 5 and we're going to multiply it by 18, and we're going to get 90 grams per mole. And that will be the water portion of my hydrated crystal. Okay, now that I've moved them off to the side, I can show you that we can take the 120 grams per mole for the salt and the 90 grams per mole for the water, and we will get the total of 210 grams per mole for the entire magnesium sulfate pentahydrate, which is 5 waters.